Hey guys, so some of you asked me to review and to go over some of the nuclear chemistry basic information in order to support you. So here we go. To make a very long story short, radiation, which we hear about all the time, is not necessarily anything bad. As a matter of fact, radiation from the sun is a good thing. It's the whole reason why our planet even exists. From this word radiation, it just means waves coming off. You have a lot of different kinds of radiation, and sometimes that radiation results from an unstable nucleus. So if I have an atom and the atom's balance of neutrons and protons are off, sometimes it will cause some instability. We call this instability radiation or radioactivity. So when you see movies and they talk about things that are radioactive, it's as if it's going to make you have 3 arms and 7 eyeballs, and none of that actually really happens 99% of the time. We are exposed to unstable nuclei, unstable elements all the time, and they don't usually cause any kind of genetic damage. Okay, so when these nuclei that are unstable interact, it can go one of 2 ways. We either can have nuclear fission, which means to break apart, or we can have nuclear fusion, which means to put together. So nuclear fusion is what happens on the sun. That's how all the elements are created in our universe, theoretically, is, one hydrogen atom with a proton of 1 crashes into another hydrogen atom with a proton of 1, and now we've together made a compound that has 2, which would be helium. And then helium runs into another hydrogen, so we have a 2 and a 1 together, and now we've made lithium. So this process happens all the time in the sun. Nuclear fusion harnesses, back up. Nuclear fission harnesses a tremendous amount of energy, which is why people have nuclear power plants. They're immensely efficient in terms of making energy. The problem is it's potentially dangerous. Nuclear fusion, like the sun, is way more energy comes from that. That kind of makes sense because the sun powers our entire universe. Well, not our universe, I say a galaxy. And so nuclear fusion is one of those things we want to do. It is theoretical on this earth outside of the sun and the planets doing that. I said planets, just the sun, and other stars doing that. But we're not quite at a place where we can do that on a regular basis. Okay, so when things fall apart and they transform into different elements, there are several different types of ways that they can break up. You can make a proton. Okay, so that's just a proton, and we're all familiar with protons. They have a mass of 1 and an atomic number of 1. We could make a neutron, okay, which has a mass of 1 but an atomic number of 0. That's a neutron. You're probably familiar with these symbols. We have an electron. Okay, that's an electron, which are 2,000 times smaller than this proton, but an opposite charge. We also have something special we call a positron, which only happens some of the time. And positrons are really, really small like electrons, but they're positive in charge, which is not the same as a proton, which is a lot bigger than this positron, 2,000 times bigger. So we have neutrons, we have protons, we have electrons. We also can have alpha particles. So alpha particles can be written in two different ways, but let me explain what it is. So a normal helium atom has 2 protons, 2 electrons, and 2 neutrons, right? But an alpha particle doesn't have any electrons. So these 2 protons, 2 electrons, 2 neutrons are gone, and instead we have 2 electrons. I'm sorry, just the 2 protons and the 2 neutrons. So we sometimes write that as 4,2He. Some books will accidentally leave off that 2 plus. That 2 plus is because it's out of balance. It doesn't have those electrons. Sometimes it can be written as just an alpha symbol, the Greek letter alpha, or an alpha symbol with the 4,2. This is the one you'll see most often. And again, a lot of times books are slightly inaccurate and they will leave this 2 plus out. When this 2 plus is left out, it implies that you have all 3 of these in balance when you basically don't. So these are the the different types of particles you can find. You can find a proton, a neutron, a positron, an alpha particle, and sometimes this electron is also called a beta particle. And when it is, it's written with a beta symbol. And there's one last one that we talked about, and that's gamma. The gamma particle is written with the gamma symbol, but it's basically just sheer energy, so it doesn't really affect anything. It's just kind of like a byproduct. So when the sun gives off energy and makes compounds, it makes the compounds and it gives off the energy. That energy is gamma. All right, stay tuned to the next video to show you how to actually balance these reactions.